Here we go with lesson 3 on non-proportional linear relationships. Okay, so the variables x and y, we consider them to be in a proportional relationship if y over x equals k or y equals k times x. So let's look right here. So y over x, let's use the pen tool, y over x equals k or y equals k times x. So in other words, the one variable is always a constant multiple of the other. And we'll see how this works. This is only ever the case when our line goes through the origin, by the way. So it's a kind of easy way to determine if you see the graph of the line. If it goes through the origin, it will be in a proportional relationship. Otherwise, it won't be. Okay, so as you might imagine, there's, only a few lines would ever go through the origin, but countless lines will go through other points and not through the origin. So this is going to be more often the case, actually, that a line does not go through the origin. So let's take a look here at our first problem. Consider the function f of x. Remember, that's how you say this. This reads f of x, and it means the function evaluated at x. All right, so we want to evaluate f of -1 and f of 3. Now, what does that mean? That means I want to look on the x-axis for this number, -1, and I want to determine what the y value is when x is -1. So let's start there and say, okay, on the x-axis, that's the horizontal, let's go over to -1. That's right here. And let's determine what the y value is when x is -1. So I go up and I hit this point, I come over, and y is 1. When x is -1, y is 1, so we can write that as when f of -1 equals 1. That says when the x value is -1, the y value is 1. Let's try to do the same thing here for f of 3. That means when x is 3. So 1, 2, 3. So when x is this, let's find out what the y value is. Going up, I hit right here, I come over to the y value, and it looks like y is 1, 2, 3. So when when x is 3, y is 3, so that would read f of 3 is 3. So when x is 3, y is 3. That's what that says. All right, so let's calculate the average rate of change of f, that's this function here, this line, from x equals -1 to x equals 3. So what are we trying to find here? Okay, the average rate of change, remember, this is a fancy way of saying average rate of change. It's a fancy way of saying slope. Okay, that is what the other name for this quantity is. The average rate of change is the slope. So let's see. So how do we calculate the slope? Well, looking at the graph, we can go to the value when x is -1 on our graph. That's right here again. And we can go to, so it wants us to go from x equals -1 to x equals 3. So when x equals 3 is right here. And remember, slope is always in that form, the change in y over the change in x. And sometimes we look at that as rise over run. It's kind of how it might have been taught in the 8th grade. So rise over run. So let's start at this first point and rise and see how far we have to go. Okay, we're going up this way. We would be running here. So we would rise 1, 2. And we would run 1, 2, 3, 4. So it looks to me like the rise over run would be 2 over 4. Otherwise, you could also say that's 1/2, I would imagine. You could reduce that. So is there a proportional relationship between the x and the y values? Well, let's see. When x was -1, we have 2 points here that we've found. When x was -1, y was 1. And when x was 3, y was 3. So let's go up to the top here again and look at what this said. So the variables x and y are in proportion. They're in a proportional relationship if y over x equals k. So some constant. K is just a constant number, so the same number. So let's see, what does that mean? Y over x. So let me take, this is my y, and this is my x, and this is also a y, and this is also an x. So if I have 1 over negative 1, what does that equal? That equals negative 1. Okay, and let's see with this other point, that was 3 over 3. So the y value is 3, the x value is 3, so 3 over 3 is 1. So does negative 1 equal 1? No, it does not. So this is a non-proportional linear relationship. And we already knew that because I told you if this line does not go through the origin, it's going to be non-proportional. Which means whenever we find the relationship between the x and the y values, they are not going to always be the same. Alright, so here's kind of some review. This the slope-intercept form of a line. Okay, so given a linear function, f of x, it can be expressed in equation form by f of x equals y equals mx plus b. Okay, f of x and y are interchangeable. They are the same thing, okay? So we could write f of x equals mx plus b if we wanted, or we could write y equals mx plus b if we wanted. Okay, so we are going to start using this notation a lot more. Okay, that's basically how we're going to see things from now on. This is called function notation, and we've talked a lot about how this works already, and we will continue to use this. So let's take a look at this question here. Given the linear function g of x, so you might say, well, what does this mean? It's just the name of the function, just called g now instead of f, no big deal. Okay, so the linear function g of x, if g of x equals 2x minus 1, let's do the following. First, let's create a table of values using the domain negative 2 is less than or equal to x is less than or equal to 2. Alright, so how do we do this? A table looks like this. We have an x, we have a y. If you want, you could put like the x comma y for the point. In the middle, you would put the function, so 2x minus 1. And you don't necessarily need all of these columns, but I think that it's going to be helpful. And then this is the domain. Remember, the domain is the set of all x's. So what does this mean? This means negative 2 is less than or equal to x. So that's the first point I want to try. And the last point, x is less than or equal to 2. So that's going to be the last point I try. And let me just try all the whole numbers in between. I could try negative 1/2 if I wanted, but that's just going to make things difficult. So what do I do here? I start plugging stuff in. So 2 times negative 2 minus 1. Well, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. So that gives me the point. Well, I'll do that after. Let's see. So here I have 2 times negative 1 minus 1. 2 times negative 1 is negative 2. Minus 1 more is negative 3. 2 times 0 minus 1 is going to give me a negative 1. Anything times 0 is 0. Minus 1 is minus 1. Then I have 2 times 1 minus 1. 2 times 1 is 2. Minus 1 is 1. And finally, 2 times 2 minus 1 is going to say 4 minus 1, which is 3. So let's see what these points are now. The first point's going to read my x value is when x is negative 2, y was negative 5. When x was negative 1, y was negative 3. When x was 0, y was negative 1. When x was 1, y was 1. And when x was 2, y is 3. So I can now take these points and I can graph the function of g. So I start with the first point, negative 2, negative 5. I go over negative 2 and down 1, 2, 3, 4, 5. Then let me go over negative 1 and down negative 3. 1, 2, 3. I go over 0, so I don't move from the origin. I just go down 1. I go to the right 1 and up 1. Then I go to the right 2 and up 3. I can now take and put a line through these points. Alright, so there's my line through these points. Put some arrows on it to show it continues in both directions. While I'm at it, you know what? I should probably label my axes and stuff. I have the y-axis up here, the x over here. Maybe label a couple points. That's 1, that's 1, this is -1, this is -1. Now I at least know how my graph is counting in each direction. Counting by ones. So there's my graph. I created the graph to illustrate the function g. Maybe the only other thing I'd want to do is just tell the reader, tell the person who's looking at this, that this function here is called g of x. The function g being evaluated at x. Okay, so let's illustrate the slope of the function graphically. What does that mean? To illustrate the slope graphically, it simply means find one point and I should say select 2 points. So how about we start with this one here and this one here. And it just means how am I moving from one of those to the other? Well, if I start here, I go up 2 and over 1. And that should work to get to every point. Let's see, up 2 over 1. Up 2 over 1, up 2 over 1. And if this were to continue, I would keep going up 2 over 1. You can see the arrow starting to point to that spot. Or going this way, the point would be down here, up 2 over 1. And again, the arrow's pointing that way. So that's true. This is going to stay constant like that. So this line has a constant slope. And we just illustrated that graphically by kind of making those steps on it. And finally, the last thing I need to do here is it says circle the graph's y-intercept. Well, that's pretty easy. I find the y-axis, that's this one, and I'm going to need to circle the y-intercept. So that means where does this line cross the y-axis? And it's this point right here. I'll circle it. Let me also label it. It's the point over 0, down 1. So 0, -1. And every y-intercept is always going to have an x-coordinate of 0 because at the y-axis, the x value is always 0. You have not moved left or right. You are right on the y-axis. All right, so let's check your understanding of this. What I'd like you to do is you can just kind of piece together a graph. You don't need graph paper, okay? It says graph the following function g of x. You can just do this in your notes. Okay, make sure you have the axes like this, label this one y, this one x, put a couple dash marks going in each direction. Okay, we're not looking for perfection here in this graph, we're looking for make sure we have the right idea. And what you're going to need to do is graph this function. If that means you need to make a table, then you can make a table. If you want to use the slope-intercept form, then you can use the slope-intercept form. And then afterwards, what you need to do is use that graph, pick 2 points off that graph, and calculate the average rate of change. And I'm not going to tell you what that means. You can go back in the notes and find out. We've been working with this a lot. You find the average rate of change and verify that it's equal to the slope of the graph. Okay, and you should be able to know what the slope of the graph is by looking at this equation. It's somewhere kind of hidden in that equation. So use 2 points and verify that the slope is whatever you determine the slope is from that function. All right, I'll be checking this next class. Good luck, have fun, and I'll see you then.